Okay, so today we're looking at arithmetic series. So our learning intention is to gain the knowledge in working with arithmetic series. We'll be successful if we can calculate the sum of a series and use these formulas. The sum of nth terms is n over 2 multiplied by 2a plus n minus 1d, or n over 2 multiplied by a plus l. And where a is the first term, of the sequence, D is the common difference, and L is the last term. Okay, let's do some examples. Here we have an arithmetic sequence, because they're just terms. So 3, 6, 9, 12, 15, 18. So it's, we're adding 3 to the previous number. All right. So notice that 3 and 18, if you add those two together, it makes 21. And 6 and 15 also make 21. And 9 and 12 also make 21. So if we wanted to add, so if I turn this sequence into a series, so I've said 3 plus 6 plus 9 plus 12 plus 15 plus 18, right? It's actually 3 lots of 21, which gives me a sum of 63. So if I have 6 terms, so if n equals 6, and a, the first term is 3, and the common difference, and L is the last term, 18, right? I can find the sum of, using this formula, n divided by 2 multiplied by a plus L. So n in this case is 6. 6 divided by 2 multiplied by the sum of the first and last term, 3 plus 18, which gives me 21. 3 lots of 21 is 63, which we calculated before. Okay, so that's by using this formula. S is the sum of 6 terms is equal to n over 2 multiplied by a plus L. Okay. Here, let's do some examples. We want to find the sum of 15 terms if the sequence is 4, 7, 10. Okay, so we're going to go all the way to the 15th term. And I've done the 15th term, so using the formula that we've learned before, the 15th term is actually 46. Okay, and the common difference is 3. We're using this formula, Sn is equal to n over 2 a plus L. So the sum of 15 terms, right? In this case, n is 15, so 15 over 2. My first term is 4 plus 46. So using my calculator, I get 15 over 2 multiplied by 4 plus 46 gives me 375. Okay. Now, let's use this formula. Okay, so the sum of the first 15 terms, so n is still 15, so 15 over 2. I'm going to multiply my first term by 2, so 2 times 4. My common difference, I want 15 minus 1, so that's 14, multiplied by my common difference. My common difference is 3, because I'm adding 3. Yep. Okay, so I'll clean this up a little bit. 15 over 2, 8 plus 14 lots of 3. Okay. So 15 over 2 multiplied by 8 plus 14 times 3 is 375. I get the same number. Okay. Here's an example. We want to evaluate each arithmetic series. So we want a 15 plus 20 plus 25 all the way to 535. So in this example, A is worth 15, The common difference, D, is the term minus the previous term. Okay. I actually know, in this case, I know that my last term is 535. So in this case, I'm going to use this formula that Sn is equal to n over 2a plus L. And that is on a formula sheet. It is, so this is page 1 of our formula sheet, and we have it here. Okay, so we have when we're using the nth term and the common difference, or when we know the last term. Okay, so we wanted to find, we don't know how many terms this is, so we need to find what n is. Okay, so but A is 15 and L is 535. Okay, we can find what that term is because we know that Tn is equal to A plus n minus 1d. Okay, where A was 15, Tn was 535, and D was 5. So we've got 15 plus 5n minus 5, it's 535. 535 minus 15 plus 5 is 525 equals 5n. So n is equal to 105. Okay, so we've got 105 over 2 multiplied by the first and last term. And we get 28,875. Okay. Once again, so we've got 5 plus 2 minus 1 minus all the way to negative 91. So in this case, A is 5. The common difference is 2 minus 5, which is negative 3. Okay, we want to find what this term is. So using this formula, all right, we've got negative 91. A is 5. That's still going to be n minus 1, but the common difference is negative 3. So we get 5 minus 3n plus 3. So 5 plus 3 is 8. So negative 91 minus 8 is negative 99. 3n divided by negative 3, we get 30. N equals to 33. Okay, so maybe I'll use the other formula now. I'll use Sn equals n over 2a plus n minus 1d. Okay, so n is 33 on 2. A was 5. N is 33, so that's 33 minus 1. And the common difference is negative 3. So cleaning that up, you still get 33 on 2. 10. That becomes 32 times by negative 3 is negative 96. So 10 minus 96 times it by 33 on 2, I get negative 1,419. One more example, so we've got 14 plus 11 plus 8 to negative 43. A would be 14. D is 11 take away 14, which is negative 3 again. Yeah. Using this formula to find out what term is negative 43. Yeah, so we've got 14 plus n minus 1, negative 3. So 14 minus 3n plus 3, so that's 17. So negative 43, take away 17 is negative 60. So n equals 20. All right, I'll use this last term. So Sn, I really should put in that. So Sn equals n over 2a plus L. So S of 20 is 20 on 2. A was 14, and my last term was negative 43. I would get, so 10, 14 minus 43. So S of the sum of the first 20 terms is negative 290. All right. We want to find out how many terms of the series 80 plus 73 plus 66 plus are needed to give a sum of 495. Okay, so in this situation, I don't know what my last term is, but I know what A is, so that's 80. My common difference is 73 minus 80, which is negative 7. Okay, and so looking at this, using our formula, we've got Sn equals n over 2a plus n minus 1d. So I want to find how many terms. I want to find what n is. So I know that that's 495. I want to find what n is. I know what a is, which is 80. Still want to figure out what n minus 1 is, or my nth term, but I know my common difference, which is negative 7. Alright, I'm just going to get rid of that 2 by multiplying that to the other side. So that's 990 equals n. 2 80s is 160 minus 7n plus 7. Alright, so 160 plus 7 is 167, then multiplied by n, minus 7n squared equals 990. And if I move everything to the left-hand side, I get 7n squared minus 167n plus 990 is equal to 0. So I get a quadratic. So now I can use my quadratic formula to figure out what n would be. So 167 plus or minus negative 170 squared minus 4 lots of 7 times 990 all over 2 lots of 7. Okay, so if I plug that into my calculator, okay, 167 plus 167 squared minus 4 lots of 7 times 990 over 14, I get 90 over 7, okay, which is 12.85. Okay, now I'm trying to find what n is, so I'm not going to use the negative value yet. So if I did the negative value, I would get 11 terms. So because this is a quadratic, the sum of 495 happens straight away after the 11th term. Yeah. So in this situation, so I tested both sides. So there will need to be 11 terms for the series 80 plus 73 plus 66 to make a sum of 495. Okay. Right. Let's look at the second last example. The sum of the first 5 terms of our arithmetic series is 110. So S5 equals 110. And the sum of the first 10 terms, so S10, is 320. We want to find the first 5 terms and the common difference. So, okay. So, what we could do, so remember, using the formula that Sn is equal to n over 2a plus n minus 1d. Okay, so in this situation, n would be 5. So S5, sum of the first 5 terms is 5 over 2a plus 5 minus 1, which is 4d. Okay, so we've got, and that equals 110. 2a plus 4d, or 110 divided by 5 on 2 is 44, is equal to 2a plus 4d. Okay. So similarly, so we got S10 is equal to 10 on 2a, which we don't know. N is 10, so that's going to be 10 minus 1, which is 9, and d we don't know. So 320 equals 5, that's 2a plus 9d. So 320 divided by 5, divided by 5, 64, 2a plus 9d. Okay, now using simultaneous equation, what I'm going to do is I'm going to subtract 2 from 1. So 44 take away 64 is negative 20. 2a take away 2a is 0. 4 take away 9 is negative 5d. D must be 4. Okay. If D equals 4, and we're going to sub that back in to 1, equation 1, right? I get 44 equals 2a plus 4 times 4. So that is 2a plus 16. 44 minus 16, we get 28. So a equals 14. Therefore, the terms, the first 5 terms, right, would be 14, and we're adding 4 to each. So 18, 22, 26, and 30. Yep. Okay. Last example. The 20th term of the arithmetic series is 131. So T20 is 131. And the sum of the 6th to the 10th terms is inclusive is 235. We want to find the sum of the first 20 terms. Okay, so let's do work with this one. So if t, the 20th term of that, so remember that Tn equals a plus n minus 1 d. So T20, so 131 equals a plus 19 d. Okay, that's the first one I figure out. So the sum of the 10th terms and the 6th term inclusive. So what I'm going to do, rather than sum of 6, I need the sum of 5, right? Because if you think of it, I've got okay, so from here to here is 235, right? So I need to know what the sum of this part is, yeah, to subtract it, because S of 10, right, will give me all of those terms. Okay, so that's going to be 10 over 2, 2a, which I don't know, 10 minus 1, so maybe do 10 minus 1 of d, and then I'm going to minus that from 5 on 2a, 5 minus 1 d, so that's 5, 2a plus 9d, 5 on 2, that's 2a plus 4d, and that all equals 235. So 10a plus 45d minus 5a, negative 5 on 2 times 4 is negative 10. Okay, so that becomes 5a positive 35d equals 235. Okay, so what I'm going to do is I'm going to sub equation 1 into equation 2. So 5a is 131 minus 19d plus 35d, which equals 235. 5 times 131, 5 times 19, so we get negative 60d so d is equal to 7. Okay, so now I've found the common difference. We want to find the sum of the first 20 terms, so I really still need to find a. So sub d equals 7 into 1. So we get 131 equals a plus 19, lots of 7. So a is worth negative 2. Okay, so to finish this off, we need to find the sum. So we're going to use n over 2, 2a plus n minus 1 d. So the sum of the first 20 terms is 20 over 2. A is negative 2. This will be 20 minus 1, which is 19. The common difference is 7. That's 10. Negative 4 plus 19, lots of 7. plug that into our calculator. Is 1,290. Okay, and that's it.